Greetings, programs. Welcome to Stegosaurus Studios. My name is Mike, and we're out in the shop. And so the big news of the day is I actually hit 100 subscribers. I guess I didn't really think that I would that would be very many people to watch this. So I'm flattered, and I'm thankful. So I hope those of you that are subscribed are enjoying. So thank you again. It does mean a lot to me. I have no idea what this episode's about because for the first time I'm actually recording ahead of time instead of at the end, so like I normally do. So let us see what Squirt does. Well, so actually there is one thing that I do know we're going to talk about in that episode, and that's this. So, and I forgot to get a little part, so bear with me while I go get this thing. So I met with my partner in Droid crime, Malcolm, and we went over this thing, the drive assembly. A couple of small changes. The big thing, though, is so we both agreed this is a Neo motor with the gear that's on it. And the one thing, this has actually moved in quite a bit. When I had it initially assembled, the gear was quite a bit further out on the shaft. And we both thought that was putting too much stress on the hyperdrive, too much shaft deflection. So changed the design to move this gear closer to the motor, to minimize that shaft deflection. So what that ended up doing, though, is now the shaft actually sticks through this plate. So one of the changes I had to make was to add this slot here, so that the shaft can stick through. So you see I've reassembled it. Gear is much closer to the motor. And so I went ahead a couple days ago. I placed the order with Send Cut Send for the plates. And of course, being me, I forgot to order 2 sets. I only ordered 1. And by the time I realized I hadn't ordered 2, it was too late to change the order. So I'm just going to wait until I get the first set of plates in and assemble the motor, the whole assembly, and then I'll check to make sure all the fits are good before I order the second one. So maybe this was a good thing. Maybe I needed the opportunity to double check everything once it's aluminum. So that's that. I have no idea, like I said earlier, I have no idea what else is going to be in this video, so stay tuned. Well, hello. All right, so the plates, the aluminum plates for the drive have come in. In fact, both sets have come in. I've already done some testing, so this is the assembled motor here. I still have some temporary spacers in there. The aluminum ones, Malcolm he's going to cut them on his lathe, but in the meantime, I can do testing with these temporary 3D printed ones. So I will show in a minute the setup and actually demonstrate that it works. But first, I want to briefly just talk about brush versus brushless motors. So I'm using the Neo motors from Rev Robotics. Those are brushless. So sort of, I guess you call it old school. Brushed motors have been around for a long time and they work fine. So brush motor, basically the housing called the stator of the motor houses the permanent permanent magnets. And then the rotor that rotates on the inside has the copper coils of wire, and they generate a magnetic field when they're energized. So they either repel or attract to the magnets that are in the stator. So then as the shaft rotates, as and those copper windings rotate, there's a brush that makes contact with a commutator that supplies power, and each half revolution every 180 degrees, there's two brushes, and one, so they swap positions, and basically they reverse the polarity of the magnetic field, and so they're attracting, and then they reverse and repel, and then attract, and so that's what keeps the rotor spinning. So a brushed motor, that's a brush motor. So a brushless motor basically moves the windings to the stator and then puts the permanent magnets on the rotor. So you energize not all of the windings, but certain ones of the windings to create an attraction to those permanent magnets that spins the rotor. And then you basically change which windings are energized to keep it running. And there are some sensors called Hall sensors that detect where in the cycle the rotor is, so that it knows, the motor controller knows which of the windings to energize to keep it running. I won't go into all the pluses and minuses of brushed versus brushless, but for a robot, when you're driving a robot in particular, brushed motors, because they wear, those brushes wear down, they can lead to, you can have two identical motors, but they don't drive at the same speed. And so you can actually see this sometimes, people that have a brushed motor R2, it doesn't drive straight. It starts to veer off because one motor is getting more power than the other. So I don't want that on the robot. On this Droid, I want to be able to drive straight. And so brushless motors are generally, in most categories, better, most measurements better than brushed. They are more expensive though. And I realized I haven't turned this thing on yet, so I'm going to pause the video and be right back with the full setup. All right, we're back. So it's all plugged in, and I'm actually going to, if you'll bear with me, I'm going to come over here, get behind the camera. So we have our transmitter, we have the drive. So the Neo motor here is hooked up to a SparkMax. So this is the motor controller. This is what operates the Hall sensors, and the three phases. So there's three wires because it's a three-phase brushless motor. So it is the motor controller. It operates all that stuff. Let's go over here. We have a battery supplying power to, I just have a couple of terminal strips acting as buses. We have a step-down transformer to take the 12 volts from the battery down to 5 because the receiver, the TDR18, runs on 5 volts, won't run on 12. This is it's from Sure Robotics. Chris James at Sure Robotics makes these. So I had one laying around on the bench, so that's what I'm using. So, and here we go. And then the other direction. So these Neo motors can really kick it. They're fast. The eventual setup. So right now I'm just running a straight PWM signal from the receiver right into the SparkMax controller. So eventually I won't be doing that. I will everything will be run through an ESP32 and the signal will go out from there because we're gonna we need to do mixing, and there's different mixes based on different driving modes. So that's more complicated than we can handle. Basically, between some mode setup on the fancy transmitter and then the software in the SP, we'll will be sending all that signal, but we'll still have to have the SparkMax controller. It's just instead of a PWM signal coming from here, it'll be a signal coming from an ESP. So pretty happy. There's a little bit of chain noise. Chains are noisy. If I want to be quieter, I'd put a belt in, but I think it's going to be great, and very excited, and gotta start working on the frame. Yeah. All right. So I'm actually going to end the episode here. This might mean that this episode's a little short. So I have finally started the CAD, the 3D, the Fusion 360 CAD for the frame. What's really been problematic for me is figuring out the front steering and suspension. I kind of feel like I'm Thomas Edison. I've, took however many thousands of tries to not make a light bulb. And I feel like that's what I'm doing. I've invented many ways to not steer a speeder bike because various different failings. I now have two methods that will work, and I'm gonna think about them and actually hopefully sit down with Malcolm and get his opinion. But I have started on the main frame and the rear suspension because that's been figured out. Although we did have to make one change. I think what the next episode is probably going to be is a little less building and a little more theory. Probably show some CAD stuff and talk about the different designs of the frame and how the frame is going to work. So anyway, thanks for tuning in. I'll talk to you next time.